Hi dear students and viewers, welcome back. In this video we are going to discuss about the kinematic equations. Kinematic equations when a particle is moving with uniform acceleration, and kinematic equations of a particle when the body is moving with non-uniform acceleration. So this is the topic for this video. Before going to start the video, dear students, if you are first time watching my channel and my app, so if you are watching my YouTube channel, then subscribe to my channel and press the bell icon too. After watching the video, if you can understand very clearly and you can feel that it is useful for to the other students, then share my channel to your friends also. So, and next thing, if you want to write the online exams, for that you have to download my app and Vinay Kumar Basics of Physics. It is available in Google Play Store. So without late, we are coming to the topic. What are the equations of motion? Equations which can explain the motion of the particle, they can be called as equations of motion. Clear? So mainly there are three equations of motion are there. Here the equations of motion should be related to some physical quantities like displacement, velocity, final velocity, initial velocity, acceleration and time. The equations what we are discussing, they are related to these physical quantities: displacement, final velocity, initial velocity, acceleration and time. Here there are four main equations are there. Among them, the first one is here V is equals to U plus AT, and second one is S is equals to UT plus of AT square, and third one is V square minus U square is equals to 2AS. So these three are the main equations. Along with them we have Sn is equals to U plus A of n minus of, and fifth one is the S is equals to V plus U by 2 into T. So these are the equations of motion. Among that, what is U? Initial velocity. What is U? U is the initial velocity. Clear? And what is V? V is the final velocity. Clear? For example, if the body is moving along the x-axis, if it is starts at the origin, so then the time is t1 and its velocity is u. After some time it is at having a velocity v. Like that, the body is moving along the particle is moving along the positive x-axis. Then u is the initial and v is the final. So you have to observe, we are discussing the equations with uniform acceleration, equations in case of uniform acceleration. And now here S is the displacement covered. Here for example, at the time t1 displacement is s1 and it is s2, then displacement is what? It is s2 minus s1. Clear? The displacement covered. When the body is moving along a straight line, we will consider distance and displacement both are similar. That's why there is no need of any confusion in the terminology distance and displacement in case of a straight line motion. And now here obviously what is A? A is the acceleration. In this case what we are taking, acceleration is uniform. And what is T? T is the time. And we have Sn, and this equation also written as like this: Sn is equals to U plus A of S, what right here, 2n minus 1 by 2, or Sn is equals to U plus A by 2 of 2n minus 1. We can write like this also. That's why there is no need of any confusion. Here Sn, Sn is the displacement covered in nth second, and this is the displacement covered in t seconds. So displacement covered in nth second. For example, here same example we are taking. So initially the time should be here t1, and then the displacement is here s1, and after some time t2 we are saying that some 10 seconds, and the final displacement here is s2, displacement covered. So this is the s1, and now it is s2, and the total displacement we are taking is here 200 meters in 10 seconds. 200 meters in 10 seconds. Now what is here n value? Here n is equals to here 10. So here 200 meters in 10 seconds, that should be, here it is s. Displacement in t seconds, how much here? 200 meters in 10 seconds. But actually what it is here, Sn means what? Distance or displacement covered in nth second. So we may take this, maybe it is 9th second or 8th second or 7th second. The displacement covered in particular 1 second, either it is 9th or 8th or 7th or 6th, whatever may be. The displacement covered in particular 1 second, that is what? Sn. So these are the physical quantities or terms what we are using the kinematic equations. See once again, u is the initial velocity, v is the final velocity, s is the displacement covered in t seconds, and a is the acceleration. What is the acceleration? Change in velocity with respect to time, and t is the time. Sn is what? Displacement covered in nth second. These equations are the when the body or particle has uniform acceleration. Uniform acceleration is available, and these also mentioned in form of scalar form also, we will call that. And for example, here if the body has zero acceleration, when acceleration is zero, how these equations can change? So very simple, you have to substitute the a value is 0. Then what it is? V is equals to u, 0 into t, and second one is what? S is equals to ut, and third one is what? V square minus u square is equals to 0, 2 into 0 into s. Then obviously what it is? V square minus v square is equals to u square. That implies what we get again? V is equals to u only. And fourth one, Sn is equals to u, and fifth one is what it is? Same again, S is equals to v plus u by 2 into t. So obviously we will consider these two only main equations when the body is having some zero acceleration. Initial velocity equals to final velocity, and S is equals to ut. When there is any change in velocity, then only acceleration is possible. If acceleration is not zero, means that what? There is no change in velocity. That's why initial velocity is equals to final velocity, and S is equals to ut. So these two equations we will consider when the acceleration is zero. So these are the equations of motion when the body is having zero acceleration. And if the same equations are mentioned in vector form, the same equations of motion can be mentioned in vector form. They can be written as like this. So simply how we can write? V arrow is equals to u arrow plus a arrow and t. And second one is s arrow displacement is equals to here u arrow t plus half into a arrow t square. And third one, v square minus u square. So v into like this, v arrow, that is minus u dot u, we will write like this. That is what here 2a as like this. And fourth one also same thing, here Sn arrow is equals to u arrow plus a arrow n minus half. And fifth one is same thing, here s arrow is equals to v arrow plus u arrow by 2 into t. So these are the equations of motion in case of vector form. Vector form, the body has uniform acceleration. So simply here, they are the equations of motion when the body has uniform acceleration. Dear students, when a particle or body moving with non-uniform acceleration, how the equations of motion can be taken, on which method we can depend? We can depend upon the two methods. One is the integration and one is the differentiation. So here kinetic equations when the body is moving with non-uniform acceleration. So for example here, differentiation. When we consider differentiation, how the equations are there, let's see here. First thing, we know that what it is. V is equals to ds by dt. Rate of change of displacement is what we call velocity. Then obviously what, right? ds is equals to v into dt. Clear? So this is the first one. And next one is here. Already we know that what it is, acceleration. How we can write acceleration? A is equals to d by dt of v or dv by dt. Rate of change of velocity, what we call acceleration. And now here, third one, A is equals to dv by dt. From that what here, dv is equals to a into dt we can write. Clear? And third one is A is equals to dv by dt, and this equation can be written as like this: dv by ds by dt by ds we are going to write. That means what? ds by dt of dv by ds. Then this equation can be written as how it is: A is equals to ds by dt means what? V. A is equals to v into dv by ds. From that what here, A is equals to v into dv. Therefore a into ds is equals to v into dv. So this is the another equation in case of differentiation. ds is equals to v into dt and dv is equals to a into dt, and ads is equals to what? v dv we can write. So these are the equations in case of differentiation when the body is moving with non-uniform acceleration. Here v into ds by dt, and the should be written as ds is equals to v into dt. It's clear. And a is equals to dv by dt, that is also written as dv is equals to a dt. And next one is what? Here a is equals to v into dv by ds. So these are the equations we are going to use when the body is or particle is moving with non-acceleration. Here the question is when the differentiation is preferable, when we can use the differentiation. So to symbol here, to change the displacement time, that means what? We are comparing the displacement with respect of time. That should be changes into the velocity of the body with respect to the time, and again from velocity to the acceleration. Clear? When displacement compared with the time, that is if you want to convert the displacement into the velocity to the acceleration, then this differentiation is preferable. You have to remember that one. Already we know that rate of change of displacement is what? Velocity. Rate of change of velocity what we call acceleration. And here what you know, a is equals to v into dv by ds. So simply here, first what you have, displacement is there, from that what you got, velocity got, and from that what you got, acceleration. Again this equation can be changed as like this. That's why to convert the displacement to the velocity to the acceleration, then differentiation is preferable. You have to remember that one. So now when the integration is preferable, same thing here, the body is moving with non-uniform acceleration, but the second one is here we are going to take the integration. When we can prefer the integration method, that is you have to know. So then conversion of, for example here what you said, displacement to the velocity to the acceleration with respect of time. Okay, To change the displacement to the velocity, velocity to the acceleration, we can prefer differentiation. But in this case, acceleration to velocity, velocity to the displacement. So to convert the acceleration to the velocity, velocity to the displacement, then we can prefer the integration method. So how these equations can be written in form of integration, let's see here. The first thing is what here? ds is equals to v into dt. ds is equals to what? V into dt. So simply here we are differentiating on both sides like this, integral v dt. Clear? Then what you get here actually here? Then integration of dx is equals to what? X. Like that here s is equals to integral v dt. Integral v dt. So obviously the limits what we are taking, for example I am going to say 0 to s. Here it is t1 to t2. Then obviously what we get s is equals to integral v dt. That means what? If we can integrate the velocity with respect of time, then only we will get the displacement. Just now only we discussed acceleration to velocity, velocity to displacement. Then only integration is preferable. S is equals to integral v1 v dt, and here that is what you have to say here, t1 and t2. Again what we can take, v is equals to what, vu plus v is equals to u plus at. So that is we will discuss in the derivations clearly. And next one is, second one is what here? A is equals to dv is equals to what? A dt. dv is equals to what? A dt. So here integral dv is equals to what? A into dt, v1 to v2, and that should be what it is here, integral t1 to t2. Clear? So integral dv is equals to integral a dt. So here how we can write? What we get here? V integral v1 v2. v1 is the lower limit and v2 is the upper limit. Then here what write? A dt we can write v1 to v2. Sorry, t1 to t2. Clear? Then what is v2 minus v1 is equals to integral a dt we can write. So this is the another form of the equation. So this is the first one and this is the second one. Clearly. And now third one is there. Third one is what is here? Same thing here. Integral ads is equals to integral ads is equals to what? Integral v dx. Integral v dx. Integral ads is equals to what? Integral v dx. This is the another equation. So again limits, the boundaries are what? s1 to s2 here, and here it is x1 to x2. Clear? So ads is equal, sorry, it is ads is equals to v dv. It is what? V dv. So limits are now what it is? v1 to v2 we can write. So these are the equations we can use in case of integration, and these are the equations we can use in case of differentiation. So very simple. I am going to write three at one place. Look here, very simple. So s is equals to integral v dt, and next one is what? v2 minus v1 is equals to what? Integral a dt, and third one is what? Integral ads is equals to what? Integral v dv. Integral v dv. So these three are the equations we are going to use in problems when the body is moving with the non-uniform acceleration. And in this case what is? v is equals to dx by dt is first one, and a is equals to dv by dt is second one, and third one is a is equals to v into dv by ds. Clear? Now we will see the derivations of these equations, how we can derive the equations by using the integration method. Let's go for that. How the equations of motion can be derived by using integration method? In that one, first we have to go for derivation of v is equals to u plus at. So just now only we discussed what is a is equals to dv by dt. We know that. From that we can write dv is equals to a into dt. A into dt. So we have to integrate on both sides like this. a dt. Here dv we are integrating with respect of velocity, here integrating with respect of time, dt dv. That's why here we are going to say that now limits are u and v, and it is t1 and t2. So you may take t1 is 0 and t2 is t. Clear? Then what we know, integration dx is equals to what? X. For example, here integral dx is equals to x, and we have, if it is limits are there, we can write x a b. Here a is called lower limit and b is called upper limit. So after integration, first you have to substitute the upper limit minus lower limit, like that. So this is the formula we are going to use. You have to remember this one. So here integration dx is what? X, like that. Integration dv means what? You will get v. V is equals to, so again what you have, limits are there, v is equals to what here? U v is equals to integral a is here, we will write like this. Then what you get? V limits u v, and a is what here? Integration of dt means what? T, and limits are what? 0 t, 0 t. First we have to substitute the upper limit v minus, instead of u already here, lower limit u, and here also same thing, upper limit t minus lower limit 0. Then v minus u is equals to at, and what we write? V is equals to u plus at. So in this way we can derive the derivation of v is equals to u plus at by using integration method. Very simple. A is equals to dv by dt. From that what write? Dv is equals to a into dt we can write, and we are integrating on both sides. Here we are integrating with the respect of velocity, that's why limits are here u and v, and we are integrating with respect of time, here t1 and t2. I am going to take t1 is 0 and t2 is t. When t1 is 0, velocity is u, when time is t, the velocity is v, and we are using the formula what it is? Integral a to b dx is equals to x, and limits are a, b. A is called lower limit and b is the upper limit. First we have to substitute the upper limit, b minus a, okay, like that. So here same thing, integral dv means what? V. Integral dt means what? T. That's why we have to substitute v minus u, a of t minus 0. Then v minus u is equals to at, and v is equals to u plus at. Let's see now another derivation. Derivation of s is equals to ud plus of at square by integration method. Let's go for that. So for that we know that here what it is? V is equals to ds by dt, we know that. From that what we can write? ds is equals to v into dt. So now we have to integrate on both sides. Integral ds is equals to integral v dt. We are differentiating with respect of time here, and here with respect of displacement 0 s, here it is 0 t. And already we know that what is v is equals to u plus at, v is equals to u plus at. Substitute here, then integral 0 to s ds is equals to integral 0 to t u plus at and is dt. Then you have to write like this, ds is equals to here integral u dt plus integral at dt. We have to apply the integration separately, 0t, and it is 0t here and 0 to s. So already we discussed 0 to integral dx is equals to what? X, like that. Here integral ds means what? S. Limits are 0 to s. Here it is what? U integral dt plus here a integral t dt we can write. So then obviously here s is equals to s, 0 to s is equals to here ut 0 to t, ut limits are 0 to t plus a, and that should be children here in the form of integration of x to the power of n dx. Integration of x to the power of n dx formula is there, x to the power of n plus 1 by n plus 1. This is the formula you have to remember. Limits are from a to b. Then what are here? X to the power of n plus 1 by n plus 1. Limits are a to b. First we have to substitute the upper limit, b to the power of n plus 1 by n plus 1 minus a to the power of n plus 1 by n plus 1. This is the formula we are going to use here. So a, how it is there, t to the power of 1 it is there, that's why I ordered here t to the power of 1 plus 1 by 1 plus 1, like this. X to the power of n dx, x to the power of n plus 1 by n plus 1. Clear? And limits are what? Upper limit what is there here, b. Instead of x, what you have to substitute? Upper limit b. So b to the power of n plus 1 by n plus 1 minus here lower limit. What is lower limit? A. So what are here? Minus a to the power of n plus 1 by n plus 1. This is the formula we are going to use here. T to the power of 1 is there, t to the power of 1 plus 1 by 1 plus 1, and limits are what? 0 to t. Substitute here, first we have to substitute the upper limit. S minus 0 is equals to u t minus 0 plus a t square by 2, limits t 0. Then what is s minus 0 means what? S is equals to here u into t, u to plus half into 1 by 2 means what? S here, half into a into t square minus 0 square, that means what? T square. Then s is equals to ut plus half a t square. In this way we can derive the s is equals to ut plus half a t square. Clear? So if you want to write the notes, just pause the video and write the notes. Clear? We know that v is equals to ds by dt. From that what, right? ds is equals to v into dt we can write. Clear? And integral ds is equals to 0 to s we are taking here, integral ds is equals to v into dt, and this is the what? Final velocity. Already we know that final velocity equation what? V is equals to u plus at substituted. Now we have to apply the integration to the all the terms. So applied. Here we are doing with respect of time, that's why u is negligible, u is omitted, this constant. U integration for only dt only is there, 0 to t dt, and similarly here only integration for time only, a integration t dt. So then integration of dx is equals to what? X, like that. Integration of ds is s, integration of dt is t, and integration of dt here it is what is? T to the power of 1 is there, t to the power of 1 plus 1 by 1 plus 1, and 0 to t. Then what you get here? T square by 2. Then finally we got like this. Let's see another derivation. V square minus u square is equals to 2s by integration method. Derivation of v square minus u square is equals to 2s by using the integration method. So already we discussed what it is. A is equals to what? dv by dt, and it is also written as a is equals to dv by ds of, and dt by ds we can write. That is what here a is equals to ds by dt of dv by ds we can write. Clear? So what it is, a is equals to ds by dt means what? V into dv by ds. So if you have an idea about this one directly, you can directly go for that. So what is a into ds is equals to what? V dv. This is the equation we are going to use. Now we are integrating on both sides with respect of s. A ds, limits are 0 to s I am going to take, and here integral 0 to, or I am going to say some initial one is what? U to v dv. That is the thing here we are going to discuss. We are integrating on both sides like that. A is the constant here, simply integration constant. Clear? 0 to s ds is equals to here integral u to v dv. I already told you what it is. X to the power of n dx is equals to what? X to the power of n plus 1 by n plus 1. This is the formula we are going to discuss. A is the lower limit and b is the upper limit. Then we have to substitute the first upper limit, b to the power of n plus 1 minus a to the power of n plus 1 by n plus 1. Where we have x, first there we have to substitute the upper limit, after that minus we have to substitute the lower limit, like that. So then here already what it is, integral dx is equals to what? X. These are the formulas we are going to use in this case. So a integral s 0 s. Then after that what it is here, v to the power of 1 is there, v to the power of 1 is there, that's why here v to the power of 1 plus 1 by 1 plus 1, and limits are u to v. Clear? Then a, first we have to substitute the upper limit s, then after minus 0, and it is what, v square by 1 plus means what, 2, and v u. So then I am going to write here a into s is equals to, here it is half into v square, and limits are v minus v u. First we have to substitute the upper limit, as is equals to half into v square minus lower limit u square, then 2as is equals to what, v square minus u square. So you can bring it to this side, then what it is, 2as, that is equals to v square minus u square. So in this way we can derive the third equation, v square minus u square is equals to 2as by integration method. Now let's see an example problem on the same topic. Okay, see some example problem, it is there. Velocity time equation of a particle in a straight line is v is equals to 10 plus 2t plus 3t square meter per second. Find the displacement of a particle from the mean position at time t is equals to 1 second. If it is given that displacement is 20 meters at t is equals to 0 seconds, acceleration, second one is acceleration time equation. So he was given the velocity equation, we have to find the displacement in the first one and acceleration in the second one. So you have to think about the problem, in which method we have to follow. Here the given equation is in terms of time, that's why obviously the body is moving with non-uniform acceleration. When the body is moving with non-uniform acceleration, there are two methods we have to follow. One is differentiation and one is integration. So now which one is we have to follow? That's the thing here. First one is displacement. Velocity given, we have to find out the displacement. It means that what, v to s. S to v means differentiation, v to s means what, s, integration. That's why for the first part we have to use the integration. And second one is what, acceleration. Given that velocity, we have to find out the acceleration. So then differentiation we have to follow for the second one. Clear? Now what is the given equation? V is equals to 10 plus 2t plus 3t square. It is the given equation for velocity. So first thing is displacement of the particle from the mean position at time t is equals to 1 second. For example, it is the mean position. It is the mean position. So and it is the time t is equals to 0, and now it is time t is equals to 1 second. T is equals to 1 second. Here now we want to find out the displacement of the particle from the mean position at time t is equals to 1 second. From here to here, how much displacement it is there. And he was given that at time t is equals to 0 seconds, it is having some 20 meters. Now here we want to find out the displacement from here, mean position to the s, time t is equals to 1 second. Clear? That is the problem here. Very simple, we have to integrate that one. So what we know, v is equals to ds by dt. V is equals to what? ds by dt. From that what we write here, ds is equals to what we can write? ds is equals to, we can write v dt. V dt we can write. So now displacement is changed from here 20 meters to s, we are taking the limits are like that. And integral, what is v here? S, that I am writing here 10 plus 2t plus 3t square dt, and limits are t is equals to 0 second to 1 second. Clear? Now what we know, integral dx is equals to what? X. Like that here what we know, integral ds is equals to s. S is, limits are what? 20 to s is equals to, here now we have to integrate this separately, 10 dt plus integral 2 dt plus integral 3t square dt. We are different with respect of dt, and limits are what? 0 second to the 1 second, 0 to 1, 0 to 1. Clear? So we want to find out the s value. That's why here substitute the upper limit s minus lower limit 20 is equals to, here integration differentiation cancel, what do you get here? 10 t 0 to 1 plus, here what we know, integral by x and dx is equals to what? x to the power of n plus 1 by n plus 1 like that. Here 2 into t to the power of 1 is there, 1 plus 1 by 1 plus 1, limits are 0 to 1, plus here 3 into s 2 plus 1, 2 plus 1 by 2 plus 1, limits are 0 to 1. Clear? Then s minus 20 is equals to here 10 into t value is upper limit is 1, 1 minus 0, plus here 2 into t square by 2, 0 to 1, again 3 to cube by 3, 3 cancel, 2 cancel. Then what you have, s minus 20 is equals to 10 into 1, 10 plus here t square, 1 square minus 0 square, limit substitute, and we have as it is also like that, 0 1 cube minus 0 cube. Then what is s minus 20 is equals to 10 plus 1 plus 1, s minus 20 is equals to what, 12. Then s is equals to what, 20 plus 12, then s is equals to what, 32 meters. S is what, 32 meters. So in this way what you find, we measured the displacement. Okay, clear? And second one is what, we want to find out the acceleration. So already what is, v is equals to what, 10 plus 2t plus and 3t square. Acceleration is what, differentiation of this one, dv by dt. Then d by dt of here 10 plus 2t plus 3t square. Here there is no variable thing, that's why simply what I here, 2 of d by dt of t plus 3 of d by dt of t square. So already you have idea about the differentiation formula. What it is, d of x to the power of n is equals to what, n into x to the power of n minus 1, like that. Here that is equals to what, here 2 into 1 plus what it is, 3 into t to the power of 2 minus 1 into 2, that is what, into 1 is here 2. So a is equals to 2 plus 60, that is the expression for acceleration in terms of time. Clear? So dear students, if you can understood this topic what I was explaining in this video, then please leave a comment and like and share my channel to your friends also. If you can support my channel, then I will upload the videos regularly. Even though I have a lot of busy, I will upload regularly. So I need your cooperation and support. Thank you for watching.